Hello everyone, and welcome to this walkthrough of Worksheet 3A. You guys just took your second exam this week, and so this is the only worksheet that we're going to have in addition to that. It's the very beginning of Unit 3. So this first worksheet, we're talking about radicals and exponents. And there's a lot of little rules with these that we need to get familiar with. So let's roll through a couple of examples from the worksheet A, and we'll see how we go. So first of all, let's look at number 1. So on number 1, we're taking the cube root. Basically what a cube root is asking is what number times itself 3 times equals this, what's underneath this radical sign. So for this, there is no number that you can square or cube and get a negative 24. So we're going to have to break this up into 2 different parts. Okay, so it might be helpful to look at the list of cubes, and I have one here provided. And as you can see, negative 8 is on here. If you cube a negative, or if you cube a negative 2, you get negative 8. And negative 8 is a factor of negative 24. So I took this negative 24 and I broke it up into the cube root of negative 8 and positive 3, because those two multiply to make negative 24. So we take the cube root of negative 8 and we said that's negative 2, so that's all done. And then the cube root of 3, well, you could do that on a calculator. You get a big long decimal. So instead of doing that, we're just going to leave it as the cube root of 3. So we put the negative 2 and the cube root of 3 together, and that's our answer. Negative 2 times the cube root of 3. Okay, let's look at number 3. Number 3 is a fourth roots. So it's saying what number times itself 4 times equals this 48. Well, there is no number that does that on its own, so we have to break this up into something that does. Well, 16 has a fourth roots of 2, and then 16 goes into 48. So we're going to break this up into the fourth root of 16 and the fourth root of 3. The fourth root of 16, like you said, boils down into just a 2. And then the fourth root of 3, once again, you could get a decimal for that if you wanted, but instead of that, we'll just leave it as fourth root of 3. So it's going to be 2 times the fourth root of 3. Okay, number 5. Number 5, we're doing cube roots again. Well, looking at the list of cube roots, we see that 125 is on there. And 125, if you double that, gets you 250. So I'm going to break that 250 up into the cube root of 125 and the cube root of 2. Cube root of 125 just turns into a 5, so that's all done. And then the cube root of 2, that, we could get a decimal for that if we wanted, but we're going to leave it just like that. And then cube root of 7. The way we deal with this is the cube root of 7 turns into a fraction. So the 7 always goes on top. So this the x is being raised to the 7th power, so that goes on top of your fraction. The bottom is just what your square root is. So in this case, we're cubing it, so it's a 3. So we just say it's x to the 7/3 power, and that's just one of the properties that you want to get comfortable with. So, that's not going to break up into anything nicer, and 7's not going to divide by 3 evenly. So we're just going to leave it as x to the 7/3 power. So we're just going to say the 5 we got times the cube root of 2 times the x to the 7/3 power. So that is our answer, even though it looks really complicated. That's exactly what we got. All right, let's skip down to number 11. Okay, 11 has 3 parts to it, and what you want to do here is just reduce all the radicals best you can, and if at the end they have the exact same radicals, you can combine them. So the first one is 8 times root 2x, the square root of 2x. Well, square root of 2x, we can't break up into anything nicer, so we're just going to leave that one alone. There's really nothing to do there. Okay, the next one, however, we have the square root of 8. Well, 8 can be broken up into the square root of 4 times the square root of 2. So we're going to do that because the square root of 4 is going to turn into just a normal 2. So we do that, and for this one we get 2 root 2x. So this has the same square root of 2x that the first one had, and that's going to allow us to combine them later. Okay, last but not least, we have the square root of 72x. Well, 72 has a 36 in it and a 2, so we break it up into those. Square root of 36 is just a 6, so we have 6 times square root of 2x. So since all of these have a square root of 2x at the end, we're allowed to combine them. If they didn't match perfectly, we couldn't do anything here, but since they do, we can. So 8 minus 2 is 6, plus the 6 is 12. So we got 12 square roots of 2x. There we go. Okay, let's look at 13 real quick. 13, you have 5 times the square root of 6. Well, square root of 6 doesn't have any perfect squares in it. We can't divide 6 by a 4, so there's really nothing you can do there. So we leave that one alone. The same thing is, it's the same thing with the root 10. Square root of 10, you can break up into square root of 5, square root of 2. Neither of those are a perfect square, so you can't really reduce that at all. Well, since one of them is 5 times the square root of 6, and the other one's 2 times the square root of 10, you can't do anything to this. So we just say, you can't combine this. There's nothing to do. So we just leave this alone. All right, number 17. Number 17 is a foiling problem. This is really similar to number 16 and actually 14, 15, and 16. So I wanted to just pick one to show you how this goes. So we're going to do this just like we do any FOIL problem. We're going to multiply everything out and then just combine what we can. Well, 4 square root of 5 times 3 square root of 5 turns into 12 because 4 times 3 is 12. And then root 5 times root 5 is root 25. And that turns into just a 5. And then 5 times 12 is the 60. So that's how I get 60 up front. Then we have 4 root 5 times 2, just double the 4, and we get an 8. So it's 8 root 5. Next one, we do negative 1 times 3 root 5, we just get negative 3 root 5. And then negative 1 times 2 is just negative 2, and that's all done. Okay, so like I said, the first one turns into a 60. The 8 root 5 minus 3 root 5, well, both those have root 5, so we can combine those, and 8 minus 3 is just 5. And then the negative 2 at the end, well, that can combine with the 60 up front, so we get 58 plus 5 times the square root of 5, and that's our final answer. We can't combine anything else. Okay, let's look at 19. So for all of these, it says simplify and rationalize the denominator. So basically, you can't have a square root on the bottom of your fraction, and that's all we have to deal with on these, okay? So for this one, I have the square root of 9/7. Well, what you can do here is take the square root of the top and the square root of the bottom separately, which is nice. Okay, the top will turn into just a 3, and the bottom is root 7. Root 7, you could get a decimal, but we're not going to deal with that, so we're just going to call it root 7. So now, to get the square root of 7 out of the bottom, what we're going to do is multiply this by root 7 and root 7. The reason you're allowed to do that is because root 7 divided by root 7 is just 1, and you can multiply anything you want times 1, and it won't change your answer. It'll just make it look different. So 3 root 7 up top is what we get. And then root 7 times root 7 on bottom just turns into a normal 7, and that is done. So we have 3 root 7 divided by 7. Okay, number 24. Number 24 has a couple square roots on bottom, and they're being added. Okay, so to undo that, what we're going to do is multiply by what's called the conjugate. What this is going to do is, this is kind of like when you have x plus 4 times x minus 4, how the middle term cancels off. That's exactly what's going to happen on this. Okay, so let's go through and see what we get. So 2 root 6 on top minus 2 root 3, and that's because I distribute the 2. On bottom, square root of 6 times square root of 6 is square root of 36, and that will just turn into a 6. We get square root of 18 minus the square root of 18, and those are going to cancel each other out, which is exactly what we wanted to happen. And then square root of 3 times square root of 3 is square root of 9, and that boils down into just a 3. So ultimately, what we're going to get is 2 root 6 plus 2 root 3 over 6 minus 3. The 6 minus 3 just turns into a 3, and we call this done. There's nothing else, nothing left to do. Okay. So that's how you do all those. Now, last one, let's look at number 29. 29, we have two roots multiplying, but before we multiply those, we can reduce this a lot. So square root of 98 can be broken up into the square root of 49 times the square root of 2. Square root of 49 is just a 7, so we call this 7 root 2. Square root of 128. I could have pulled out a better number at the beginning, but I wasn't sure what the biggest number was, so I knew that 16 times 8 was 128. So I did square root of 16 times square root of 8. Square root of 16 turns into a 4. Square root of 8 can be broken down further, so we get square root of 4 times square root of 2. The 4 can be reduced to a 2. So ultimately you get 4 times 2 times square root of 2, and that is just 8 root 2. And then down here at the bottom we have 7 times 8 is 56. And then root 2 times root 2 is just root 4. Root 4, if you take the square root of 4, you get 2. So we get 56 times 2, and we get 112. And that is our final answer on that. Okay, so that concludes all the ones I'm going to do on worksheet 3A. If you have any questions or get stuck, just look at the answer key that we have on Schoology. And if you get really stuck, feel free to email me, and I'll try and sort you out. Okay, that is it. If you have any questions, like I said, email me or bring them to class, and I'll try and do them for you in there. All right, thanks a lot. Have a good day.